Hi, I'm Tom Cook, Sales Manager of Southwestern Controls and Fluid Solutions. I would like to share with you today some aspects of hydraulic and lubrication filtration in aerospace and industrial systems. Let's consider filter component integrity. We've already discussed that no leakage is imperative, and this is a case history of a bypass construction where we had a competitor who came in with a very competitive bid. However, when we took apart the component they were offering, we found out that instead of the very reliable no leak tapered poppet on a tapered seat, they offered a less expensive and irregular construction that was a washer that was spring-loaded. It provided too much leakage, which eroded the efficiency of the filter, and it did not get the customer to the ISO cleanliness levels they desired. Similarly, with housings, you want to consider that they're both serviceable, that they line up well, that any spring-loaded component is doing its job. Collapse ratings are extremely important because if you have a low collapse element that gets into a differential pressure situation when loading, the filter will collapse. So you might want to consider high collapse rated elements. The Southwestern Controls Fluid Solutions media is worth considering its construction. It consists of an upstream and a downstream epoxy-coated wire support. Sometimes with super high collapse elements, it's stainless steel. And then it has a microfiberglass multi-depth pre-filter layer. Moving inward, you find the micro and nano fiberglass multi-depth efficiency layer. There is the possibility of an optional integral hydrophilic layer. And then finally, the last layer is a diagnostic or cushion layer that has no filtration capabilities, but it's there actually to cushion the construction as well as it can serve as a diagnostic tool. Microphoto illustration of a comparison between microfiberglass and paper. You notice the engineered strands of the micro-nano fiberglass on the left as compared to the very irregular two paper structures on the right. Paper is a natural structure that grows randomly, and it depends upon what kind of tree or what kind of cellulose it's processed from, how it's processed, but it's not as regular as a man-made construction. Let's consider a few aspects of the advantages of microfiberglass over paper. You might notice that certainly the micro-nano fiberglass, just because of its close layers, can be much more efficient than the open structure of the paper. Harder to perceive is that the pressure drop across the micro-nano fiberglass filter media is lower than that of the paper media. Actually, the micro-nano fiberglass has more open area, although it's very close together. But you can look at performance charts and you can verify that. Now, dirt accumulates, contaminants accumulate around the strands of each one of these fibers. The reason that micro-nano fiberglass has such a high dirt holding capacity is because it's got more nooks and crannies, more strands to accumulate. Dirt doesn't just stay out in the netherlands of the filter, it has to light on some kind of a structure. And since the places that dirt can land is greater, that's how the micro-nano fiberglass has 3 to 5 times the dirt holding capacity. Finally, consider that the micro-nano fiberglass is completely impervious to water. We know what happens to paper gets in water. Even if they tell you it's a coated paper, water's going to get in there, and it's not only going to cause the paper to swell, but it's going to cause it to shed and go downstream, which is not an issue with the nano microfiberglass construction. Not all microfiberglass is created equal. Here's a microscopic illustration of some inferior media that are just taking fiberglass strands and not particularly putting together in an engineered structure. Other considerations include pleat support. Pleats need to be properly supported, or they will result in one of two possibilities: either pleat pinch off or pleat collapse. Southwestern Controls fluid solutions filter elements are pleat optimized. This kind of gives you an illustration of what we do. You start out in a configuration where you might consider, okay, let's go with 55 pleats within a given filter configuration. And we see there that with 55 pleats in the construction, it will be able to hold about 130 grams of dirt. Let's get the pleats supported, but still closer together to about 65, and we can see that we could go up in excess of 140 grams of dirt. And then the ultimate optimization is at about 75 pleats, and there we can get 160 grams of dirt holding capacity. If we go too far, however, and we get the pleats in count up to about 85, we find that actually it has less dirt holding capacity because the pleats are too close together to be able to effectively gather dirt. And if we go overboard and go to 100 pleats, we'll find that we've drastically reduced our dirt holding capability. So our filters are pleat optimized to be able to hold as much dirt as possible due to the number of pleats. And in this particular illustration, we're talking about 75 pleats as being optimal. It's important that the pleats are supported with the epoxy-coated carbon steel wire during service so that they don't pinch or bunch. And in fact, some manufacturers have a non-supported pleat that's too tight, and effectively, you don't get full use of your pleats in that type of configuration. Spin-on cans can be a problem because whoever looks inside spin-on cans. Sometimes we do, and we look at it. This is an actual photograph of a new filter that we took out of a new can. And not only was it improperly bonded, but the paper had gone through an oven and was parched, and yet they put it into a spin-on can and called it a filter in new condition. Another look from a different angle shows how irregular the epoxy coating was in this process. So if you're using a spin-on filter, do some consideration on what's inside. This challenge with a wood products company that had multiple locations, they called us in and said a competitor had come in and was going to replace us and be about 20% less expensive. So in front of the customer, we took apart the two spin-on filters and we cut apart the pleat packs. And at first look, you can see that the Southwestern Controls Fluid Solutions filter looked very similar to the competitor's filter. We took apart the Southwestern Controls Fluid Solutions spent pleat pack right in front of the customer. You'll notice in this photograph of that, you'll see the inner and the outer epoxy-coated carbon steel wire support layers. Coming up from the bottom, you'll notice the dirtiest layer is the dirt holding layer that gets the bulk of the contaminants. Rising above that, you'll see a layer that's slightly pink, and that's the efficiency layer that's taking out the very fine particles. The next snow white layer is the cushion layer, which supports all of the pleats, but it also can act as a diagnostic tool because since it's snow white, it's showing you that there's no contaminants that got to that particular layer. Otherwise, it would be discolored. Next, we looked at the competitive, supposedly identical offering. Customer was shocked to see that it only had 3 layers instead of 5, to which we remarked to the customer that he should be getting at least 40% off since they only have 60% of the component construction. Now, notice that all that filter consisted of was a dirt holding layer and then a remay layer and 1 support layer. If you look at the white areas of the contaminant layer, you'll notice that that filter was not utilized because it was not properly supported. So you didn't have full capacity of that. And the dirtiness of the second layer shows that contaminants were actually getting into the customer's system. Comparing the diagnostic layers, you can be assured that the bottom layer, which is the Southwestern Controls fluid solution layer, being snow white, is assuring cleanliness within the system, whereas the contaminated competitive last layer of the competition shows that it's not fully taking out the contaminants. In a different video that you may have viewed, we talked about how you can recognize fines such as are deposited in the bottom of a reservoir. And what you'll find, since they're very fine particles, you'll find that going from left to right, the left layer is the dirt holding layer, which has not gathered any appreciable contaminants because all of the contaminants in this oil analysis were very fine particles, as indicated by the 26 of the ISO cleanliness code. So the filter, as you can examine by the third layer, the snow white layer, wasn't allowing the dirt to go past the filter. However, there was an inordinate amount of fines being deposited on the second layer. You can do quite a bit of discovery outside of a laboratory analysis just by simply running the contaminants across filter patches and discovering what the nature of the contaminants are. It can be followed up with a laboratory analysis. When you're considering oil and filter analysis, you want to make available all the necessary tools to do so, which includes gathering the evidence, filter patches, seeing what's depositing on the outside of the filter, doing a formal lab analysis, and some photographic comparisons with typical dirt distribution and typical contaminant microphotos. At Southwestern Controls Fluid Solution, we're experienced and capable to handle a wide variety of contamination system and hydraulic and lubrication fluids. Call us to give us an opportunity to work with you on your issues. Contamination variation can be very complex. You can attack the problem through a detailed oil analysis. Let us know how we might be able to assist. Thank you for your attention.